Aluminum wiring can cause electrical problems and safety hazards, particularly in older homes. One of the main issues is oxidation. Aluminum oxidizes easily, forming a corrosion layer that increases electrical resistance and generates heat. Aluminum wires are more fragile than copper wires and prone to breaking, especially when bent or flexed. Aluminum has lower electrical conductivity than copper, requiring larger wire gauges for the same current capacity. Overheated aluminum wires can weaken over time and increase the risk of electrical fires. You might see signs of problematic aluminum wiring, such as loose or flickering lights, buzzing or humming noises from outlets, scorched or discolored wires or terminals, tripped circuit breakers or blown fuses, or electrical shocks or sparks. Improper installation of aluminum wiring can exacerbate these hazards. Wires under screws should be twisted securely, not just jammed. This ensures a good electrical connection and prevents wires from being pulled out. Loose connections can generate heat and lead to arcing, which can damage wiring and increase the fire risk. Staples driven too tightly can cut into the aluminum wires, creating weak points and potential safety hazards. Rewiring a home with aluminum wiring is a major undertaking that should be performed by a qualified electrician. In some cases, it may be necessary to replace the entire electrical system. However, there are also less invasive options available. One is pigtailing. This involves adding short copper pigtails to the ends of aluminum wires before connecting them to outlets and switches. Another option is COPALUM connectors, using special connectors designed to join copper and aluminum wires safely and securely. A third option is circuit breaker replacement by installing circuit breakers specifically designed to protect aluminum wiring. Aluminum wiring can pose significant electrical hazards, especially if it has been improperly installed. If you are working in a home with aluminum wiring, it is crucial to take necessary precautions and consider rewiring options to ensure safety and prevent potential problems. Aluminum wire was introduced as a cost-saving measure during a period when copper prices were high. However, its inherent properties present several challenges when used in residential electrical systems. One significant issue is the coefficient of thermal expansion. Aluminum expands and contracts more than copper with temperature changes. Over time, this can lead to loosening of connections at terminals, creating gaps that increase resistance. Increased resistance leads to heat buildup, which further exacerbates the expansion and contraction cycle, potentially leading to arcing and fires. Another problem is galvanic corrosion. When aluminum comes into contact with dissimilar metals, such as steel screws or copper components, in the presence of moisture, an electrochemical reaction can occur, leading to corrosion. This corrosion increases resistance and weakens the connection. Aluminum oxide, which forms on the surface of aluminum when it is exposed to air, is an insulator. This means that it does not conduct electricity well. Therefore, when making connections with aluminum wire, it is crucial to remove the oxide layer and use a joint compound that prevents it from reforming. This compound typically contains zinc particles that create a conductive pathway and prevent oxidation. When aluminum wiring was first used, many electricians did not have adequate training or proper materials to work with it. This resulted in many installations where the wires were simply wrapped around screws without proper cleaning or the use of joint compounds. Additionally, standard electrical devices such as switches and outlets were not designed to accommodate aluminum wire. The terminals were often made of steel or brass, which are incompatible with aluminum. These factors contributed to a high failure rate and increased risk of fires in homes with aluminum wiring. The Consumer Product Safety Commission, or CPSC, has issued guidelines and recommendations for dealing with aluminum wiring. These include having a qualified electrician inspect the wiring, using approved repair methods such as pigtailing with COPALUM connectors, and replacing standard devices with those specifically designed for aluminum wire. Pigtailing involves attaching a short length of copper wire to the end of the aluminum wire using a special connector. The copper pigtail is then connected to the device terminal. This creates a more reliable connection and reduces the risk of corrosion. COPALUM connectors are a type of crimp connector that are specifically designed for joining aluminum and copper wires. They create a gas-tight seal that prevents moisture and air from reaching the connection, thus preventing corrosion. These connectors must be installed by a certified electrician using a special crimping tool. Another option is to replace the entire aluminum wiring system with copper wiring. This is the most expensive option, but it is also the most effective way to eliminate the risks associated with aluminum wiring. When replacing aluminum wiring, it is important to ensure that the new wiring meets current electrical codes and that all connections are made properly. Circuit breakers play a critical role in protecting electrical circuits from overloads and short circuits. In homes with aluminum wiring, it is especially important to use circuit breakers that are specifically designed to protect aluminum wiring. These circuit breakers are designed to trip more quickly in response to overloads and short circuits, which can help to prevent fires. When working with aluminum wiring, it is essential to follow all safety precautions and to use the proper tools and materials. Always turn off the power to the circuit before working on any wiring. Wear appropriate personal protective equipment such as gloves and eye protection. Use a wire stripper that is designed for aluminum wire to avoid nicking or damaging the wire. When making connections, use a torque screwdriver to ensure that the screws are tightened to the proper torque. This will help to prevent loose connections, which can lead to overheating and fires. Inspect aluminum wiring regularly for signs of damage or corrosion. Look for loose connections, discolored wires, and melted insulation. If you find any problems, have them repaired by a qualified electrician immediately. It is also important to educate homeowners about the risks of aluminum wiring and the steps they can take to protect their homes. This includes advising them to have their wiring inspected regularly, to use only approved repair methods, and to replace standard devices with those specifically designed for aluminum wire. In addition to the hazards mentioned earlier, aluminum wiring can also be more susceptible to damage from rodents and insects. Rodents may chew on the insulation, exposing the bare wire and creating a shock hazard. Insects may nest in electrical boxes, creating a fire hazard. Therefore, it is important to seal any openings in electrical boxes and to take steps to prevent rodents and insects from entering the home. The National Electrical Code, or NEC, provides specific requirements for working with aluminum wiring. These requirements are designed to ensure that aluminum wiring is installed and maintained safely. It is important to be familiar with these requirements and to follow them carefully. Some older homes may have used a type of aluminum wiring known as solid aluminum wire. This type of wiring is particularly prone to failure and should be replaced with copper wiring. Another type of aluminum wiring is stranded aluminum wire, which is more flexible and less prone to breakage. However, even stranded aluminum wire can pose risks if it is not installed and maintained properly. When inspecting aluminum wiring, it is important to check the wire gauge. Aluminum wire must be larger than copper wire to carry the same amount of current. If the wire gauge is too small, it can overheat and cause a fire. For example, a 15 amp circuit typically requires 14 gauge copper wire. However, if aluminum wire is used, it must be 12 gauge to carry the same amount of current. Similarly, a 20 amp circuit typically requires 12 gauge copper wire, but if aluminum wire is used, it must be 10 gauge. The ampacity of a wire is the maximum amount of current that it can safely carry. The NEC provides tables that list the ampacity of different types of wire. These tables take into account the wire gauge, the insulation type, and the ambient temperature. When selecting wire for a particular application, it is important to choose a wire that has an ampacity that is sufficient for the load. In addition to the wire itself, it is also important to consider the connectors and devices that are used with aluminum wiring. Standard connectors and devices may not be compatible with aluminum wire and can lead to corrosion and failure. Therefore, it is important to use connectors and devices that are specifically designed for aluminum wire. These connectors and devices are typically made of aluminum or are coated with a corrosion-resistant material. When making connections with aluminum wire, it is important to use a joint compound that is specifically designed for aluminum wire. This compound will help to prevent corrosion and will ensure good electrical connection. The joint compound should be applied to the wire before it is connected to the terminal. When tightening the screws on the terminals, it is important to use a torque screwdriver to ensure that the screws are tightened to the proper torque. Over-tightening the screws can damage the wire, while under-tightening the screws can lead to a loose connection. The proper torque value will be specified by the manufacturer of the connector or device. When working with aluminum wiring, it is important to be aware of the potential for galvanic corrosion. Galvanic corrosion occurs when two dissimilar metals are in contact in the presence of an electrolyte, such as moisture. The electrolyte causes one of the metals to corrode. Aluminum is particularly susceptible to galvanic corrosion when it is in contact with copper or steel. To prevent galvanic corrosion, it is important to use connectors in devices that are made of aluminum or are coated with a corrosion-resistant material. It is also important to keep the wiring dry and to prevent moisture from coming into contact with the connections. In some cases, it may be necessary to use a dielectric grease to prevent galvanic corrosion. Dielectric grease is a non-conductive lubricant that can be applied to the connections to prevent moisture from reaching the metal surfaces. Aluminum wiring can be a challenging material to work with, but with proper training, tools, and materials, it can be installed and maintained safely. It is important to be aware of the potential hazards and to take the necessary precautions to prevent problems. If you are not comfortable working with aluminum wiring, it is best to hire a qualified electrician to do the work for you. They will have the knowledge and experience to ensure that the wiring is installed and maintained safely. In addition to the information provided earlier, here are some additional points to consider when dealing with aluminum wiring. Always use antioxidant compounds specifically designed for aluminum connections. These compounds help prevent oxidation and ensure a good electrical connection. Follow the manufacturer's instructions carefully when using these compounds. When terminating aluminum wire, ensure that the wire is properly sized for the breaker or fuse. Use the correct size terminals and connectors. Oversizing or undersizing can lead to loose connections and overheating. Regularly inspect the connections for any signs of corrosion, looseness, or overheating. Use a thermal imaging camera to check for hot spots in the electrical panel and its outlets and switches. If any issues are found, address them immediately. Consider installing arc fault circuit interrupters or a size to provide additional protection against electrical fires. A size are designed to detect arc faults, which are a common cause of electrical fires, and to shut off the circuit before a fire can start. Aluminum wiring requires special attention and care to ensure its safety and reliability. Always consult with a qualified electrician if you have any concerns about the aluminum wiring in your home. If you are considering buying a home with aluminum wiring, have a thorough electrical inspection performed by a qualified electrician. This will help you identify any potential problems and make an informed decision about whether to purchase the home. Remember that aluminum wiring itself is not inherently dangerous. However, it requires careful installation and maintenance to prevent problems. By following the recommendations outlined in this discussion, you can help ensure the safety and reliability of aluminum wiring systems. The key to dealing with aluminum wiring safely lies in understanding its properties and taking appropriate precautions. Proper installation, regular inspections, and the use of compatible materials are essential for preventing electrical hazards. Remember, electrical work can be dangerous. Always prioritize safety and consult with a qualified electrician when in doubt.